Cheers. Thanks for coming.
Nice.
That's it.
Thank you.
Cheers.
Thank you. So, thank you very much. Thank you for coming. You never get thanked, and you're as important as anyone else here. So, some of you are probably thinking, wait a minute, I saw this fellow in October. I saw pretty much it's the same talk, and what's the story here? Am I having a matrix, glitch in the matrix type situation? The long and short of it is, yes, you are. I was working on this, taking the talk from October, moving it on, and I just kind of scheduled end of summer to have it all done by. Then we had a problem here, so the speaker who was due to be here today was not available, and I have kind of I've done the usual IT deadline thing of just so there will be some raggedy edges and whatever. I apologise for that in advance. Just to get a level set, how many people were here in October, or not here, down there, and actually remember the talk? Oh, hands go down when I say and remember the talk. I like it. Okay, so for the 1, 2, 3 of you, good news. It's not exactly the same. You can see the little new and improved sticker down there. That's what has changed. But also bad news. The first part of it is exactly the same because I have to explain event sourcing before I can explain what you do with it. And I haven't been able to come up with anything better than this show and tell type thing. So, agenda, fairly straightforward. I'll explain what event sourcing is. I imagine that you've heard the word, probably seen it, definitely used it. You may not realize you've used it, but a lot of systems are built on event sourcing. To give you an example, source control, washing machines, everything. It's all event sourcing. But I explain what it is, then why I've used it. We can have a little sort of chat about why you might use it or why you might not use it. And finally, I'll get into sort of how I have done it and how it is possible to do, or a way of being possible. Some sort of pre-flight check notes here. I'm not going to show you any code, no explicit language. The reason being that when I ever see code at one of these things, I immediately get into the sort of mode of, well, that's not the language I would have chosen to do this. And I hope that this idea or architectural design, whatever, is applicable to most languages. It works really well with functional languages, so any Scala or F# people, whatever, will really straight away understand this. People like me from the previous century will have a bit more difficulty, but you can do this in object-oriented languages and, well, presumably everything. The other note is that I'm sort of pitching this at a beginner with a little bit of intermediate level. Basically, the obvious reason that I'm not an expert, so I can't teach you at expert level. If you want to take this to an expert level, go onto YouTube, look up Greg Evans, follow his several hours of talks, and by the end of that, you'll know probably more than I do, which is always a good thing. So, start with the demo. The idea here is a very simple demonstration of event sourcing as compared to a model-based database system that I always used to work with, and I presume that you have done. The Hello World example is a very, very simple bank system. I think it's appropriate given where we are. I should just point out, this is not production ready. So a very simple bank, minimum viable product, we're just doing the counts. So this is our empty table. Essentially what's going to happen is people are going to come into the bank and start depositing money. This being Ireland, they will then take it away again pretty quickly and so on. But we have their empty table. As people come in, start doing something, we start filling up. So we'll use my nephews as scapegoats for this, but imagine, so Aidan comes in with his pocket money and he deposits that. I should actually stand this side. So he's a very wealthy young man, so he gets 10 quid. His sister May comes in. She also gets 10 quid because they're a very equitable family. And Fergal, well, I'll probably spell wrong and get into a lot of trouble, is behind him in the queue. He only puts 5 quid in because on the way to the bank he's already spent the other 5. So, end of day one, boom, done. Aidan sees what Fergal has spent the money on, decides he wants that. He comes in the next day, takes away the takes his money out, and is left with 5, and so on. So you can just see, standard bank account. As time goes by, this always gives you a perfect view of what your current state of everybody's account is. So, exactly how much everyone has. If you want to know how much the bank has in deposits, you go straight down there. It's really simple stuff. The obvious problem with this is you are losing 90% of your data, because every time someone does something, you just apply that something to the data, and you've lost the sort of extra meta information on what caused it to be a £5 thing. Most people who work in financial systems, you will have another table off here called transactions, maybe another transaction details, transaction types, etc., hundreds of tables. But the basic end result is you're storing the current view of the data, and you're kind of keeping audit trails off there. Event sourcing, which I'll go over there and produce thing. It's a very different idea. So it's the other way around looking at the data. So instead of looking at the current state of the data, you store every single bit of history of how we got to where we are, and then to get the current state, you just play through the history, work out what you're doing. I'm going to introduce some definitions, but probably get them wrong, so do pull me up on this. The first thing is people talk about aggregates. I use aggregates perhaps in a too wide a way, but basically what I'm talking about when I talk about aggregate is anything that can be uniquely identified and that events can happen to. So in this example here, our accounts can be uniquely identified and events can happen to them. So that's our aggregate. And then obviously event, anything that happens that changes the state of your aggregate or entity, whatever. So we'll throw up some dummy aggregates here. These are the aforementioned unpaid nephews, nieces, and so essentially exactly the same idea, except that to start, when the person comes in, first thing they're going to do is they're going to say, okay, they're going to open their account with $50 there, 50 euros. I've Americanized that. And so he opens his account. She actually transfers money across. I don't know if it's he or she, so apologies for that. So that came in from a different method than that. But anyway, you started your thing. Deposits are going on. This should demonstrate how parallel this is. If I had 3 hands, it would. But anyway, so this is all going on. Here we have sales tax, because we're in Ireland. This person couldn't be bothered. They closed their account. This person got some interest, and so on. So, up it goes. And then they got a credit card fee and some sales tax as well. So what we have here is the accounts expressed as their history. The rules for an event stream, very simple. You can't take an event off. It's like Fight Club. Rule number 1, no event may be taken from the event stream. And rule number 2, no event may be changed once it's on the event stream. So the obvious thing you're going to say is, well, people type stuff in, they type it in wrong, how do you deal with that? The way that you deal with that is, for the wrong record, you create a compensating, like a fixing record. So let's imagine, so the account closed. That was a mistake. I pressed the wrong button on the poorly designed interface, close the account. How do I deal with that? You don't take that event off, you put another account opened event on, and basically that gives you your current state. So that's the background. To get data out of these wonderful things, you do what's called a projection. So you basically run up the history. Projection is a really, really simple piece of code that cares about 2 things. The first bit is a filter that says, do I care about this event type? The second is, if I do, what do I do with the data that's in that event type? So as we're in a financial company, I will do the first nice easy one is a profit and loss thing. Profit and loss for a bank account is, it's got 2 events there. If interest occurs, your profit and loss goes down, because you, the bank, have paid interest to the client. And if a card fee occurs, your profit and loss goes up. So essentially, if you want to know what your profit and loss of any given account is, you take the projection, you run it across the event stream, and you come up to the end result. Now, where this is quite powerful is you can stop anywhere. So if you want to know what your P&L was yesterday, you run it up until yesterday, and so on. Or you can also, depending on how you set it up, you can also have the projection basically being a live thing, so an actor-based object is one of the best ways to do it. So essentially, as events happen, the projection gets updated. So that's basically it. A more complex one, the account balance. Again, for each different event type, we just go through, and if we care about the event, we do the action. So transfers in, we care about, they increase the balance. Interest we care about, you increase the balance, and so on. So basically, more complex, but the same idea. When you're writing a projection, it's actually quite a good idea to make the projection as simple as possible. So doing things like averages can be a much more complicated thing, because you're keeping lots of data in the projection itself, plus and minus, whatever, that's really easy. The added advantage is if your projection is immutable, you can cache that as well. So, I get my balance here, I can take this, I can put it on a CDN, I can pass it to the Japan office, or send whatever. It's still a fact, it's still correct. There is no problem, there's no open transaction, rollbacks, redoing, whatever, because as at the time the cache was taken, it is a truth. It's an unchangeable truth. Later events can come along, can alter that projection, and then you would have a later cache. So essentially, you get another stream of caches here, so you can do that. So that's the demo, and that is kind of the most important concept of this. So I'm actually going to stop here. Say, are there any questions or things I could clarify? Anything like that? Anyone got any statement that's preposterous because? No?
I was wondering what you would do in the case of you had a very large event stream.
That's a very good question. You can cache a certain point if you have a very can't think of a better word than boring. If you're an event stream that has a few kinds of events, you can actually take a meaningful starting point snapshot. The problem is that as soon as you do that, you've lost all your history. The way that you do this, if the CFO is not in the room, is you just add more hardware, basically. Because, well, I mean, the long and the short of it is computers are cheap, memory is cheap, people are expensive. So this, whatever. And actually, the Lego gives a kind of a wrong impression of the growth. You can actually put an awful lot of events into something and store it on a thumb drive. I have so I work in a company that does stuff for hedge funds and pricing and stuff like that. But one of the things that we do is asset pricing. But because each asset has its own event stream, the event streams are in the order of megabyte. So that loads handily in memory, blasts straight through it if you want to get a price history of something or whatever. But they are quite undifferentiated, better than boring, undifferentiated event streams. Event streams with things like sales tax and whatever, you shouldn't ever truncate them because you've lost very valuable data. Because basically, let's say, the previous way of using data and software or whatever was towards a defined goal. The current way is people say, what can I discover about my clients, my business, etc. from the data? So that's basically, don't throw stuff away, go into a meeting and justify having another hard disk or whatever it is. They get cheaper. In fact, even since we started this talk, they've got cheaper stuff. But it's a very good point, and it is one of the biggest things that scares people off is, well, if you're running that projection, surely it takes forever. Totally valid, and what I would say is just try it on the hardware you've got, because actually it's not particularly bad. And the reality is that inside an RDBMS, something similar to this is happening anyway. The transaction log of a database is, it's cleverer than this, ish, but it's that, So you can do that. The other question you often get is, so the example I did there is, you get the sum of how much is in the bank, you just go straight down there, select some, I'll give it a better name, select some amount from table, you get the total. It becomes more tricky when you have this, because if you want to do that, you have to run the balance projection for every thing, and then essentially it's a kind of map reduce. So the balance gets to here, the balance gets to here, the balance gets to here, you put them all in a queue, and you pass them over to a whatever your function is, so a sum function. Is that okay, or is that lost anyone, or is it? Okay, so the advanced stuff, which I've got working, but I haven't really, I'm not 100% on. So this could be nonsense, and in which case it's going to be a very interesting talk for me as my boss next time when this goes to production. But essentially, the other question with databases is how do you do the sort of where clauses? So in that, select star where balance is greater than 10, you get Mayback. That's really simple. Same thing here. How do you do that kind of thing here? You again have to run the projection for everyone who's in the potentially could be in the result set, and then pass that through a filter rather than through an aggregate. And that feels slow, and if you have huge sets of, if you have like all the assets that are listed on Bloomberg or whatever, that is slow. There's no question about it. And in some businesses, that will be a deal breaker. My business is not, because you very rarely do anything where you say, give me the average price of 20 uncorrelated things, or that kind of thing. But in something like maybe bank accounts, that could happen. The way that you deal with that, or you improve that kind of idea, is that you create what I call business meaningful sets. So a business meaningful set for a bank system could be open accounts, accounts in credit, and whatever. And then you write classifiers. So a classifier basically is something that runs over the event stream and decides whether your event stream is inside that group or outside that group. So, open accounts, the classifier is very simple. If you don't hit this as your last event, the account closed event, you're in. If you do hit that, you're outside the classifier. And then what you do is you nest those. So I'm only going to run the balance projection against things that are in the accounts open group, or group, and so on. So you end up with basically you're doing the minimum amount of querying that you have to, but the way that once you have selected the group that you have to query, you do have to run the projection and then pass it over to your aggregate function or your filter function. Okay. Yes.
Would you have the same event in multiple places? Would that make sense?
No. An event can. Oh, I saw. Okay. Advanced fight rule rules. An event can only happen to one thing, and even if the same business event happens to different things, they each get their event. So if I transfer money from John to May, two things will happen. John will kill me, but also two events have to happen. And in most ledger-based systems, two events do happen anyway, because people work this out in the 1600s that you have to have complicated things. Applied interest is not an event, because apply interest to John is an event, apply interest to May, and so on. Apply interest to everyone is a higher level, it's a command. And I'll get back to, so that I am getting onto, it's where the new and improved bit is now, so how do you take this on to the next level? So, apologies for having to skip back here. So the next question is, when you're doing these things, you have in your database, whichever you've chosen, you have a graphical design tool. You can draw out your relationships, your constraints, etc., and you end up with a beautiful model. In an event-driven system, I'll stand out of the way here, it's not as easy because all you can really design is you can define the aggregates. You can say these are the things in my system which I know or I can uniquely identify and can have things happen to them. So I've put that in the middle. Apologies for the blurriness, but that's bank account there. So that's each one of those has that. The question then is what events can meaningfully happen to this. So again, for each event, so bank account opened, bank account closed, money deposited, money withdrawn, etc. Those events can occur, and those events have properties such as the date, the amount, and so on. And each event can have its own definition. Then what you can do is you can take these events and you can have a projection, and the projection basically you're drawing lines to say projection cares about that event and that event, doesn't care about that, doesn't care about that. And then within the projection you have access to the data of the events that you care about. So in this projection, the running balance projection, which is this one here, you have access to the money withdrawn event and all the data in the money event withdrawn event. You will actually use the amount field and say, add that to your running balance. Ignore all the others and go on to the next bit. So that model, as you can see, kind of looks a bit databasey, and you're like, oh, that's lovely, I can understand that. The problem is this is the model for one single entity aggregate type, and in a real business model, you soon get lots of those. You don't get as many as you get tables in a database because you do not need to do the sort of nonsensical join tables that are just many-to-many relationships turned into a thing, and you don't need to do data lookup tables or whatever, currency-to-currency code or whatever, because that's you can just put the currency in the event and have it as a as data, or sorry, as a drop-down list. So, but you do end up with a big model. So what I would suggest for this is basically model your aggregates independently. So your bank account events, and then your customer events on a different page, customer in the middle, different events, because even though in your mind, in your business, the same event has occurred to the customer and the account, it's not the same event. What the account cares about or how the account is changed by the event is different to what the customer account cares about and how the customer is changed by the event. So you would actually have different event definitions. You can use the same names because obviously it inherits the aggregate name, so it's account.money deposited and then client.money deposited, or whatever you want to do it that way. So modeling, this is something I did myself. It's not the best way of doing this, but it's okay. If you want to do this kind of modeling, one of the best ways to do it is to actually go the full whack and do your analysis using event storming. Have you heard of that? Yeah? So very simple. Instead of looking at your entities and how they all draw together, you actually look at what are the things in your business, what events can happen to them, and then what order do they happen. You just basically end up with a huge long strip of paper with little stickies on it. This is my event, my account, sorry, and these are the things that can happen to an account. And you basically don't care what you get out of it, you just care what you are putting into the database or into the data system. And then having stored all the data you can, everything you can find out about your events, whatever, you then work out, well, what can I use this for? So it's not goal-driven modeling, which is what you would do with a database. It's just kind of like wide open stuff. And again, in my experience, that is a difficult one to explain in your sort of first meetings when you're starting out a project, because it's not how things are always done, and things have always been done perfectly, so we don't need to change. We do, obviously. But the other thing is that there is a belief when you come to write a piece of software, people believe that it is possible to model the entire universe, or even the bit of the universe that your system will sit in. I've been programming for about 25 years now. I don't think I've ever got even close to being able to fully model my system, because the reality is you're modeling the bit that you know about inside your company that is happening now. And that's all you can know. And tax rules change, strange things happen all around here, constantly messing up your model. And so, basically, that is one of the reasons, in my opinion, where for basically the whole throw the system away and start again is your model has changed so much from how it started. It's become a mess. What you would do with this system, when the same situation occurs, you add a new event type. Your existing projections don't get affected in any way, unless you choose to make them affected, obviously. But basically, you can alter this model in a very low risk way. If I add a new event type to this, don't even need to recompile any projections or whatever, because if they don't need to know about it, they don't know about it. They just, do I care about this event? I don't know what it is. No, on to the next one. You can version events. So you can say, okay, in version 1, I knew about these properties. However, the thing's been live for 6 months and we've discovered these new things that we can know about our property. So we decided we're going to store what the weather was like when the person came in to deposit money. It might be useful. So the way you do that is you add a little version number tag, and then you have to change your serializing of the event or however you're going to store it. So how you're going to store it needs to know which version it's reading back from the database to know whether those fields can be populated or not. Again, that's something that has been solved in programming. We do versioned persistence and things like that. There are many good libraries that do it. It's basically a solved problem. But that's what you get with your model. And as I say, if you are doing it, do a nice color one like this, because when you go to show your manager, it's not as terrifying as saying we don't really know what the system is and it's mostly going to consist of events and code and whatever. That's quite a leap to get to that. So getting to the next bit. So I did this before, and I don't think I had enough experience myself to really talk confidently about this. But I've kind of grouped things together now. So business fit, we'll start with that one. If your business already works this way, you'd be surprised how easily the business people totally understand it, and they're like, well, that's the most obvious thing I've never heard. Why did you put it in tables that didn't make any sense? So financial services, everything, IoT, whatever, like things that happen by events. People tend to think in events if they haven't been trained, using CODS laws and all that kind of stuff. People think in events. As soon as they have been trained in CODS laws, they don't. Which brings us on to this problem: ease of use, tooling, developer experience. There is obviously a bit of a ramp on this, or a mindset change, because it's really difficult to look at the thing and say, I understand the system. Whereas you can fool yourself by getting a database model and say, I understand the system. I don't know what that field's used for. I know that table's not used anymore, etc. But yeah, I understand the system. You can't do that with this. Even if you have modeled all the events, you'll get such a huge thing. So the way that you deal with that is you compartmentalize it. If it's not your job today to think about the accounts entity, don't look at the accounts entity, because the stuff you're doing won't impact it anyway, and away you go. Tooling, not great again, but it's okay for us because event definitions are in code. So either if your language allows it, use an interface, define the event definition, etc., and then your projections can consume that interface. If it doesn't, you have to hard code it in as whatever. But it's code. It's very very straightforward and readable. And the other thing, the ease of use, is if I get a bug and it's in production and I happen to know that something wrong with, let's say, May's account. If I want to debug that, I literally just take a copy of the event stream, put it on my machine, and step through. And I have, in that event stream, I have everything that happened to the one in production. So there's no artifacts of some other thing, some other table being different, some configuration, nothing. Everything that can happen to the entity, aggregate, whatever, is in the entity or aggregate. So that makes a big difference. The first time you're basically, something weird has happened in production and you're actually able to step through a reliable copy of the production data as it happened in production and see what's going on, it changes your feeling about it anyway. Well, it did for me. So. The biggest ones, people, like, this is terrifying. Performance scalers, because when I'm describing this seems like I'm telling you that a lot of work is going to happen. It's going to be really slow. And if we were in the world of monolithic great big servers, you'd be absolutely right, because it would have to do one, then do the other, then do the other, and stepping through thousands of events, going and retrieve them off the disk, etc. In the cloud or microservices or whatever, in the more distributed way of doing things, like, these things are not connected to each other. So there is no reason why you can't run all the projections in parallel. Obviously, hardware constraint, but there's no logical reason. There's nothing that can go wrong. There's also no need to get too hung up on locking. If someone writes an event while you're reading, if it occurred before you got to the end, you include it. If it occurred after you got to the end, you don't include it. But because where your history is unchangeable, you don't have to worry about someone changing event 3, deleting event 5 while you're up here, which is what databases do, locking, mostly what databases do locking for. And obviously, not only are these logically separate, they can be physically separate. There's no reason why you can't put that on this machine, that machine, etc. And if you were doing the sort of where clauses and some of the filters and the aggregates, you run them all on their own machine and then pass them to a MapReduce style bit of code that does it. So again, we have solved most of those problems. I'm not including that. The good people at Google and Amazon and everyone else have solved this kind of thing. So yeah, performance is terrifying to think about, but in reality, give it a go. It's not nearly as bad as you would think. And scalability, it scales widthways, not upways. So there is one limit to scalability, and that is the number of dollars that you have. Because when you add, if this is not working fast enough, you have another machine. I would recommend only having one thread writing to an event stream, but if you're clever enough to do the thing, yeah, I can't, but I'm sure people can. But there's no limit to how many threads can read the thing at the same time. So if you are a read-heavy business, just throw more hardware at the problem and away it goes. Similarly, if you're a really read-heavy business and very few writes, you can actually take copies of this and read them in memory and be relatively happy that it's good enough. It depends on how short time scale your business can deal with, but for many things that's perfectly okay. Again, it's a discussion to have in your business. Okay, so new and improved bit, and therefore the ragged seed bit. So CQRS, everyone's familiar with this? Yes? No? Good, okay. Because if I had to explain it at a high level, I don't know either. CQRS is a very simple architecture based on the idea that you have a complete separation between the bits of your system that do commands, that change anything, and the bits of your system that do queries. And it is complete. That's the only sort of thing that people will have sort of wars about and whatever, is that separation has to be complete. When you have event streams underneath that, it becomes quite a good match, because essentially what you're doing is a command can add one or more events at the end. That's all it can do. So your commands happen here. You don't care about the query side, so that's a good separation. Your query side has to run projections. It has to do all the aggregation stuff and whatever. So obviously, if you were doing how much work is going on, the query side is doing the bulk of the work in this setup. So the query side gets the cache and gets the thing. If you want to do ad hoc querying, if your manager or your business require you to use, excuse the language, but crystal reports or something like that, the best thing to do is have your cache be a database. So when this projection finishes, it writes a row to there, last updated, whatever, and when you run your queries off that, developers know how to use SQL, so you can do all that. All I'm saying is, before it becomes SQL, it should be event source first. So you can always recreate that. You can take this to your machine and recreate that, and so on. So there's a lot more to CQRS, but it doesn't really match to this. It's like to do with how you layer it and whatever. To be honest with you, I just split it like that. So commands, update, sorry, not update, add events.
Insert only.
Insert only, exactly. There should be a little electric shock. If I say update or delete, so they append only events. And queries can take from events projections if you want. If your business model requires more flexibility, they go from there. So, okay. Any questions, objections? Oh, very good. Yes. Sorry.
How, because you talk about the Oracle and all the SQL database.
Yeah.
What if, say, I have a joint account, I put in money, in the same moment my wife is querying my account.
Yeah.
So how it's not, probably she will see 10 euro more because I'm putting 10 euro.
Well, she will see what is true at the point where she asks the question. So, if you put in 10 euro, so actually this is a demo, so this is you putting in 10 euro, you're going to be May. This is what happens, right? I get right in the way for the board, you can't read that. 20. Hey! That's your balance. That's what a database does.
Yes,
So,
there's a log in say Oracle database.
Yeah.
It has the
exactly. So if your wife asked how much money was in your account while you were adding that $10, she could get 3 answers. She could get $10 if she asked before you started adding. Yeah. She could get transaction log timed out if it was a badly written system and you were, she could get a message. Or she can get $20. All of those 3 things, like the database has enforced that, but all of those 3 things are available for this because they're true at the point when they were asked, except for the transaction log stuff, because that's just, But that's basically it. Yes, you're absolutely right. And when I'm trying to sell this to people, believe me, that's like, wait, what? Eventual consistency? I cannot have that. Well, so the tip on that is, the really tip is, eventual is a really short period of time. Like it really is. You're writing an event, and then I'm reading it with projection as a bank account, so maybe what? I mean, I'm a busy person, but I don't think I have 20,000 records in my entire bank history.
So there's no need to guarantee the consistency between.
Eventual consistency is exactly is real life, right?
Yeah.
It's like that's what happens right now, as you described. I mean, somebody puts in money in the bank account, you can't see it.
Yeah.
Then you can't see it.
Now.
So at that period of time, it depends on the system, depends on the requirements, but there is a period of time, even in transactional database, even in your ACID thing, that everything, if you stretch your transaction log, you see exactly that state, right?
Which point?
There is some point where
This is the
you
point,
can't
exactly.
see this,
Well, see, the point is the database will prevent you reading it until the write is complete. So the database will say, you can read 10, oh, the write has started, so you can't read. The write is completed, you can read 20. So it has enforced that gap. And if you absolutely have to do that, you could put a little flag on here, message not on this thing saying, I'm busy, come back later, and then whatever. But then whatever's doing that flagging, if that falls over, you've got a lock. And it's exactly, that's how databases do it. To give you an example, this is actually, I know we're in a financial services company, so I probably shouldn't tell you this, but when I was a student a long, long time ago, I used to have a card limit, there's a £20, sorry, is this what, €20? Sorry. So £20, sorry, you could only take out £20 on your card. So I would go to my own bank, put in the thing, boom, 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 get my £20, I would run around the corner, and you had to go fast. And there's about a 50% chance you could get another £20. Now, the next week, £40 would have gone from my account because they would consolidate that. But,
Oh,
you know, that was an open transaction. Now, I presume they were using databases, but of course they were two companies. So that's, you know, you can't put a transaction across a boundary.
Distributed system.
You know, it'll kill you. You know, it's a very difficult thing. You had a question as well?
Yeah, actually I have two.
Oh.
One, like you mentioned commands are like, for instance, multiple events in different
Yes.
event stream. Are those commands somehow atomic, or like what if they die at like?
Yes, they are. And actually, so that, I will come back to my answer to that, but there isn't one answer to that. There are multiple ways of doing it, and it kind of depends what your command is doing. But yes, so they are atomic from here.
Okay.
Within the system, in the same way as a database, you know, you have transaction, the whole transaction fails, you roll the whole transaction back. You obviously can't roll back things here.
Exactly.
So when you've done, but let's say did that green one, that went fine, that did not go fine, right? And that was my update, you know. So you have to work out what is the business meaning of that did not go fine. So, you know, does it mean all three of them were not fine? If it does, then for this one and this one, I need to put another event at the end of it that says, sorry about that, that last event was not reliable, ignore it, and, you know, or not ignore it, undo it, and carry on. But it depends if the event is meaningfully atomic. So the classic example will be apply interest. You know, apply interest, it's the end of the day in the bank, and everyone gets interest at 1%, let's say. So your command, apply interest 1%, comes down here, works for him, doesn't work for him, right? Put him in a queue or in a thing, and another one here saying the interest didn't work, you know? So it's kind of a poisoned situation. The next morning when someone comes in, they have to go through the small amount of things that didn't well. We're in computer land now. The next process following along will go, oh, these accounts didn't take properly, do an appropriate action. And depends on your percentages, but really this should be 5 nines or more. And the exceptions, they're called exceptions for a reason, they should be an exception. If your business logic routinely doesn't allow you to do something, it's not an exception. You need to work out, like, why am I issuing commands that aren't able to succeed? So that's, yeah. But yes, many different ways of doing that. That would be my preferred way, but that's because of the business I'm in. I don't know that, you know, if you worked in neonatal monitors or something like that, I don't think that would be an appropriate way of dealing with it. You know, there might be set off alarms, call people in, I don't know, something like that. But yes, you don't have what the database gives you automatically. You do have the decision to make. What do I do about a command that fails? Similarly, query that fails. They say, well, how can a query fail? Well, if this was marked as unreliable while the query was running, you have to make a decision. Do I run a projection on it, even though it may be unreliable, or do I ignore it, or do I kill the whole query? And again, in a database, it depends on your read committed flag, but essentially most businesses would say, I kill the whole query, and that's just it. I kill the whole query because this record is in a state I can't deal with. But you have to make that decision for your business. You know, as in my business model, that's okay. Well, unless it's an FX rate or something like that, in which case obviously you kill the whole query because it doesn't make any sense. But sometimes it'd be like, you know, the last 10 transactions or whatever, if the 10th one is not available and I'm not doing an aggregate, just show 9, that's okay. You know, it really, you know, you have to make a decision yourself, so yeah. Anyone, yes?
So in a relational database, when you do a change in a database, you open a transaction, you do your stuff, you close the transaction.
Yeah.
Something goes wrong, you roll back everything.
Yeah.
And you don't care what are the side effects because you roll back everything in a single package.
Yes.
In this case, your logic needs to understand all possible side effects and provide an additional change in the stream to roll back every single side effect. And you do not know all the side effects in advance.
You don't know all the side effects. I wouldn't say you need to know all the side effects. I think what you need to know is how your command is individualized. You know, so what does the command mean to each event stream? Because you need to then decide what am I doing for those event streams that the command didn't get to. Or what am I doing to those streams the command did get to? It depends on, is your business, but what's the database term for, like, you can be permissive for dirty writes or not, or anyway, your business model will have.
Serialization level.
Yeah, exactly. So your business model will say, I either do care that I want everything rolled back, in which case what you would do is you have to know what's being rolled back, whatever. And I will get to a little aha moment, or there won't, I don't know. But there is, how do we do this? I'm going to explain that bit a bit later, but that is really, it's a little bit weird and out there, so I didn't want to put it too early in the thing. So.
I just wanted to comment on that. Those commands are usually, in most cases, are specific, and they're for a single entity, for a single, what you call aggregate, I don't know how to, but the bounded context. So
okay.
all this thing has to happen together, but it is a very small unit of work. Yeah. So in that scenario where you do calculate interest, there would be a command for each group of logical things that need to happen, and like I said before, they would be successful, or 99.99% successful, otherwise it's an exception, and each and every command works on its own bounded context, so there is no kind of what you're describing in a relational database where everything needs to happen together. This is the bounded context.
Exactly, yeah. And if
this one thing needs to happen.
If you need the level of guarantee that a database gives you, you can either roll your own around this, which is doable, or you can store this kind of thing in a database, which I really don't recommend, but people do. You lose all the benefits, but
What is the best practice to store those events?
best practice, right? This is really controversial. This will get me in a lot of trouble. There is a technology that has been developed for a long, long time. It's really battle proven. Most operating systems are fantastically optimized for it, most hardwares and whatever, for this, and it's called file. So if this is a file, this is a file, this is a file, like the hardware understands that. The hardware has been written like that. It can multi-thread, all the things that you need to do, all the hard problems are, well, again, it's controversial. There are some operating systems that don't do it very well, but this is a file. I do the storage for this on Azure, so cloud-based. AWS would be exactly the same, and their best equivalent is a thing called append blob, because it is a write-only file, which is absolutely fantastic because there's no code to delete or whatever, so you don't have to think, oh, I must remember not to delete or talk about deleting. It will talk about byte load, that kind of thing. So, that's a good example. If your system doesn't have such a thing, encapsulate it and stop out anything that does deletes and appends or updates or anything, and just end up with that. Within it, how do you store the data within it? Serialize it. Again, people like binary because it's fast or whatever, but again, these events are small, so JSON is really fast enough, in my opinion, in my experience. And the advantage is, of course, you can open the event up and read it in Notepad or whatever, it's, makes sense. But opinions vary. If you are not going to use a file, and you're going to lose some of the thing that you want to, then obviously you can see the different shapes here. That's NoSQL shape. That's so a NoSQL solution is probably better. The reason, and it is controversial, but a lot of people put this in databases. The reason you don't put this in the database is, like, every event has to have either a new table or a new small fields added to the current common table or whatever. So you will lose the point of this. And also, the best minds in the world are working on distributed transactions, distributed databases. They haven't got it yet, so it's not easy. Whereas this kind of thing, if it's kind of cheating, but if you treat each file as its own thing, and whatever, you can pass them around. You can put them, as I say, on CDNs. Like if you have an office here in Ireland, an office in the States, an office in say Hong Kong, it is meaningless to copy the database across, or not meaningless, it's a scary and terrifying thing to do. But it's quite possible to say, okay, the office closed here, right? So this is no longer can be written from Ireland. Put it on CDN or put it on a transfer, file transfer. It appears in the US office. You add more events, and it can travel around the world. However, whatever method suits you best, basically. And again, the other thing about this is that we're discussing things like projections and caches and whatever. None of those have to live on disk. Projections in memory on the machine that's on. Memory is ludicrously cheap now, actually. I mean, you could basically throw stuff in memory and forget all about it and carry on with it. Again, that's a developer opinion, not a manager opinion, or CFO opinion may vary. But if you were to create a system that has to have this held in memory, there's no reason why you would have a copy here, a copy here, a copy here, and every other projection that can happen. Whenever another event is added, they all update, and away you go.
So in this case, when you want to do debugging, just put a file from some file system,
copy it.
put into local,
Yeah.
run this thing.
Yeah. And the events are isolated from the underlying data. So if I have those events on, say, an Azure append blob or whatever, if I copy it to my machine as a file, and the same bit of find the next record logic is working, then I can run it as a file in memory and step through it and whatever. And it could be persistent on a completely different system, but it's the same thing. Whereas again with a database, if I wanted to step through a production database, I need the same RGBS on my machine. I need to develop a copy of it, and I need to set up the configuration, make sure I remember those packages and those whatever. So,
Just one more thing. Sorry.
yeah, I'll advance the slide, but I won't. There we go. Right.
Just regarding the append blob that you mentioned up in Azure a minute
Yeah.
or two ago, do you ever hit any performance or scalability bottlenecks using that approach?
Yes, performance bottleneck, which I have a thing. It's not performance. It's a bit of stupidity that basically it's really difficult to just read the most recent N events from an append blob. So you just have to read them all. So obviously, you're passing that from wherever it's stored onto the local machine, do the thing, that slows it down. What I would like to have is, let's say this at event number 700 stored, and say, okay, I want event 700 onwards from my append blob, and pass them to it, and away we go. That would be faster, but no, I haven't worked out how to do that. And I'm sure...
The event store does that, no?
The event store database, yeah, that other people's better implementations of this do that, yes. Append blob on Azure doesn't do that out of the box. So, I basically have to read the whole thing. And what's really interesting is it's kind of the reverse of normal development, because it's a lot slower when I'm debugging it, because I'm dragging the file down from Azure and onto my machine and step. When it's in production, it's actually faster, so it's kind of backwards. But anyway, that's good. Use with domain-driven design and/or microservices are going to just again some rules that are very obvious, but bear saying again. When you have microservices or domain, when you have domains, you keep them separate. So domains can only talk to each other with commands and queries. Domains cannot access each other's event stores, projections, identity groups, etc. Because the problem is, within the domain, the same event name might mean something different. Bank accounts and sales, like client in the sales platform, client here. If you start sharing the actual underlying database, you haven't got microservices anymore or event store. So it's actually microservices. Okay, if your microservices are in the same logical domain, they can share the same data, the same thing. You need to put write control on it, obviously, but that's doable. But they do have to be in the same logical domain, and there's always a temptation. Oh, I need to write a service that just does something that's a little bit different from my domain. I'll just use all the data. So again, I would put this is like a plant cell or something. So I put a hard membrane around it, so that your API, your published whatever is that command and query. Command parameters that it needs, query parameters that it needs and the data type it will return. Data type being a data structure that it returns, whether it's a set of them or one of them. But that's it. So, you know, you could put an anti-corruption layer there as well, which means that, you know, somebody else doesn't, your system changes, their understanding of your query doesn't change, and you can, you know, things like that's the big payoff with microservices, DDD, etc. is literally things can evolve independently, and if you enforce that command query separation stuff, you get a very easy evolution path. So, is that all okay, or is